Good evening. Welcome to the Case School of Engineering's online information session. Joining us tonight is Professor Frank Merat from the Department of Electrical Engineering, Computer Science, and Professor Dario Gasparini from the Department of Civil Engineering. They will be discussing majors and minors in civil engineering, electrical engineering, computer science, computer engineering, mechanical engineering, and aerospace engineering. I am Lynn Marie Hamill from the Office of Undergraduate Studies, and I'll be taking your questions via email to be answered live on air. If you have a question, please send it to summerreghelp@case.edu with the subject line Info Session. If we do not answer your question live on air, we will follow up with you shortly via email. And now to your hosts, Professor Merat and Gasparini.
Oh, thank you, Lynn Marie. I'm Frank Merat.
I'm Dario Gasparini.
And we're going to basically describe some of the features of the Case School of Engineering, which will be very relevant to you in planning your freshman year schedule. And we will also be going over typical curricula for the majors that were previously mentioned. Just starting off here, the mantra of the Case School of Engineering: we don't just engineer, we engineer a better world. Okay, first thing to keep in mind when you are scheduling and planning your entire undergraduate schedule at Case is that we have a set of courses which we call the core or engineering core. Usually we just call it the core. And this consists of the courses which are shown on the slide. Engineering 131, the computer programming course, and I'm going to come back to that because there's some options there. Engineering 145, the chemistry of materials course. Engineering 200, statics and strength of materials. Engineering 210, introduction to circuits. Engineering 225, thermodynamics, fluid dynamics, heat and mass transfer. We usually just call it thermo. Engineering 398, professional communications for engineers. Now, not all of those are taken in the freshman year. Typically, unless you have AP credit, you would be taking Engineering 131 and Engineering 145, and not necessarily in the same semester. Now, let me back up just a little bit because I told you there was something about Engineering 131 that made it special. And that is for students that are going to major in computer science and computer engineering and a few other majors such as systems biology. I don't know if there's anyone interested in that particular major with us tonight, but you would need to register for EECS 132, which is the Introduction to Java Programming, instead of the Engineering 131. All of the other engineering majors, such as civil, mechanical, electrical, etc., would be taking the Engineering 131, which will be engineering problem solving in MATLAB. Now, we have a number of programs. We have majors in 7 departments, and I always point out that we also have engineering physics as a major, and that is actually done out of the Department of Physics rather than one of the engineering departments. We've got the degrees in biomedical engineering, chemical engineering, civil engineering, electrical engineering, and computer science. And we have 4 degrees in electrical engineering and computer science: computer engineering, computer science, electrical engineering, and systems and control engineering. We've also got the degrees in macromolecular science and engineering, materials science and engineering. Mechanical and aerospace engineering has 2 majors: the aerospace engineering degree and the mechanical engineering degree. And a number of you will be looking eventually at potentially combining 2 of those degrees or potentially doing a major and 1 or more minors. And we can answer questions about those if that's something that you're particularly concerned about. Let's see, I do want to say a little something about the photo there, since it's always one that I enjoy, and that actually is taken out of one of our mechanical engineering robotics labs, and all of those little brown things are plastic cockroaches. We actually do an awful lot of what we call biologically inspired robotics research. And what you actually see, that mechanical thing in the foreground there, is actually a fairly large mechanical bug. That one's about between 3 and 4 feet long. Some of our others are bigger, some are smaller. Now, I do want to say one thing about majors. Okay, typically you do not declare your major until sometime in October, and between that time and the end of your 3rd semester. So there's not a rush. We are going to emphasize what the courses are for the different degree programs, but you're going to see that they're not really all that different in the freshman year. So you don't need to worry if you don't know what your major should be. We are going to have a lot of freshman programs sponsored by the different departments, student organizations, research groups, undergraduate studies, and all of this will help you figure out what you want to major in. And this is also something that you should be talking to your freshman SAGES advisor about. Okay, we have tons of opportunities for students to get involved. You can indeed get involved as a freshman with many of the research programs. We have a special office called SOURCE, which will, if you're interested in research, work as a matchmaker between you and the faculty, either in your area of interest or faculty who are especially looking for students to become involved in their research. We have a number of NSF-sponsored programs for involving undergraduates in research, but to be honest, the best thing you can do is simply talk to the faculty in areas in which you are interested. Or if you're simply taking a class from someone and you're interested in what's going on in the class. Okay. This is not something that you'll do immediately, but you want to keep this in mind as part of your overall undergraduate planning, and that's the co-op program. Typically, the co-op program will begin at the end of your first 2 years. Now, many students between the freshman year and the sophomore year during the summer will take intern positions, but a co-op is slightly different. An intern position typically is a 2 to 3 month experience, typically 10 to 12 weeks. So it's on the short side compared to a co-op, which is typically 7 months. The longer time of the co-op allows you to do much more significant work with the company, and we've actually had students come back from their co-op experience with patents, papers, and certainly a ton of very valuable experience. A couple things about the co-op. I mentioned that it begins at the end of the sophomore year. There's actually 2 periods in which you leave the university and go into industry, work at a company for 7 months. So typically you do your first 2 years, go into industry for 7 months, come back for a semester or 2, then go out for a second co-op period, and then come back and probably graduate not too far after that. You get paid very well. Average co-op salary is about $2,800, but it can go up to $6,000 a month. Co-op students usually have the inside track on jobs at the companies that they've co-opted with. They're typically offered higher salaries, and it is really great experience to help you make up your mind. I had one student that went out on a co-op. He was a great electrical engineer, and he came back and said, I had such a good time designing mechanical parts that I want to switch to mechanical engineering. So this can be a very important factor in helping you make final decisions in your future goals. And let me mention something about the companies. Students will co-op sometimes with local companies, national companies. We've had students go to NASA. That would be a national. It could be anywhere. IBM. We've had actually students do international co-ops. Microsoft does not have a co-op program. They have an internship program. We've got a variety of local companies. We've got big companies, small companies. Some students will start at one company. For example, at Intel, your seniority at the company starts on the day you begin your first co-op. On the other hand, you might decide to go to a large company and a small company, a West Coast company and an East Coast company. But it is a great experience and can really, really help you solidify your career goals. As you can tell, I'm a co-op advisor. Okay, you don't just have to go into industry to have experiential opportunities. We have a lot of international programs. We have some short-term programs which have developed with China, other countries in the Far East. We have the Engineers Without Borders. They've been primarily involved with projects in the Caribbean, usually dealing with clean water and/or electrical energy. And we also have the same thing in Thailand and in Cameroon. And we also have some special courses, for example, in Botswana, where students are developing off-grid electrical sources to do things like power villages, but especially to recharge their cell phones. And there are just tons of opportunities there. Student organizations. This is something that is great in terms of networking. Basically, every major will have one or more student chapters of the professional organizations. In electrical engineering, it would be the Institute of Electrical and Electronics Engineers. In civil engineering, it would be the American Society for Civil Engineers. There's the American Society for Mechanical Engineering. These sponsor all kinds of student competitions, very informational sessions. They're great for leadership development. There are also more specialized organizations, the Society of Women Engineers, the Society of Plastics Engineers. We have the Engineers Without Borders coming up again. So an important thing, and this is true of all college life, get involved. Just a few words about advanced placement. We're anticipating that you'll probably have some questions for us. Right here we're only showing some of the technical exams and their equivalents. Many of you, for example, might have taken the chemistry exam, gotten a score of 4 or 5, and that would get you out of the courses shown. For example, the chemistry 105, 106, 113. However, for students in engineering, which I anticipate that all of you are, that will get you out of chemistry 111, and then you would move along in your program to take engineering 145, the chemistry of materials. In computer science, if you get a 4 or 5, and this is again that engineering 131, EECS 132, you will get credit for the EECS 132. If you're not in computer engineering, computer science, or one of the programs that requires the EECS 132, you do not have to take the engineering 131. The EECS 132 will satisfy the degree requirement. Calculus, there's a couple variants there. In particular, if you have a 4 or 5 on the Calc AB, That would proficiency you out of the first calculus course and into the second calculus course, Math 122, which is basically your multivariable calculus. If you have a 4 or 5 on the BC, that's equivalent to our first 2 calculus courses, and you would be going into the Math 233 vector calculus course. Now that sounds a little intimidating, but one really nice thing about that particular AP is there is a review of the material that was presented in our Math 121 and 122 so that you can be sure that you aren't missing any topics. Physics is a little bit more interesting. Typically, if you take the Physics C, mechanical, score of 4 or 5, you will get out of Physics 121, which is the first mechanical, I should say, mechanics course in physics. And what will happen if you take the E&M with the same score, you do not get out of the Physics 122, which is the electricity and magnetism physics, but what happens is that you get credit for 3 hours of physics, which could be either an open or technical elective, depending upon your particular major. Okay, civil engineering.
Thanks,
Dario.
Again, I want to emphasize what Frank said. You don't have to choose a civil major until your sophomore year. The best way to get to know the departments is the way Frank described, which is to really visit each department and really participate in the activities of the department. So I have here some information of our department. Please, Jamie Hora is the president of our ASCE student chapter, and our department chair is David Zhang, and our administrative assistant is Nancy Longo. So if you want to find out about what civil engineering is, please contact one of these 3 individuals, and they will be able to facilitate your participation in our department. Also, as Frank said, the first year curriculum is essentially common among all the disciplines. And this is an example of our freshman year curriculum. The first semester you take chemistry, engineering 131, physics 121, the SAGES courses, which are the humanities courses, math 121, and we also in our curriculum have room for a humanities and social science elective. However, sometimes some freshmen who are really interested in civil engineering opt to take one course that is shown there called ECIV 160. ECIV 160 is called Surveying and Computer Graphics. So it's kind of an introductory course to the civil engineering profession. And it provides you some skills. So if you want to work in the civil engineering area at the end of your freshman year, you can always say that you've taken some surveying and computer graphics, and there are some job opportunities open with that kind of experience. But again, you do not have to choose a major until your sophomore year, and take the first year really to explore the various engineering fields. Thanks, Frank.
Okay, thank you. I'm just going to say a little bit about electrical engineering and computer science, since that's my home department. I've mentioned previously that we have 4 degree programs in the department. Our oldest is electrical engineering, which started graduating students in 1887, one of the oldest programs in the nation in electrical engineering. The computer engineering program started in 1971. We were one of the first 2 programs in computer engineering, and it was Case and Carnegie Mellon who both were accredited at the same time. Our systems and control engineering program started also in the 70s, and our computer science program was officially formed in 1987. We have a large department, 35 faculty, 219 undergraduates, broken down 71 in electrical engineering, 116 in computer science, 48 in computer engineering, and 6 in systems and control. As just a little informational point, we've had 100% employment of our graduating undergraduates for at least the last 3 years. All of the programs in EECS have a large number of technical and open electives, allowing you to customize your degree and have potentially a number of minors, and not necessarily, by the way, just technical minors. You can have a major in engineering and certainly a minor in another field of engineering, but you can also have a minor in economics. You could do a minor in a foreign language. There are many, many options there. The research in the EECS program on the engineering side, we work on sensors, microelectromechanical systems, which means we make machines on integrated circuits. We actually do electronic integrated circuits. We do a lot of robotics, hardware security, field programmable gate arrays, signal processing and optimization. The computer science research has a strong focus in bio-related areas, especially bioinformatics, data mining, databases, and algorithms. We have some really nice facilities like our computer gaming lab and the Sears Design Lab. And I just showed a couple students over here on the side. We're a very multidisciplinary department. The upper photo just shows a couple students playing electrical engineering type games in front of our main engineering building. In fact, the fellow in the middle graduated. Interesting fellow. He got turned down by MIT, but he turned down Carnegie Mellon and went to Stanford for his graduate work. Down below, and since I got to make up these slides and I'm a very robotics type person, we've got 2 robotics projects. We've got the lawnmower project, and right below it we have the DARPA Urban Challenge, which was done several years ago. And it's interesting to look at these students. I see one student in front who went to the University of Texas, Austin. Another one went to Maryland. I notice up above in the lawnmower photos, we've got some electrical engineers, mechanical engineers, a computer engineer, basically very multidisciplinary groups. And I will point out that a number of these students especially came on to these research programs as freshmen, and in some cases sophomores. The fellow at the far right in the middle picture actually walked on as a freshman and stayed with us to do his bachelor's degree and his master's degree. And just very, very successful and a lot of fun. And by the way, we put in our application for a brand new robotics challenge, which will be done, hopefully we'll get it, with Case as the lead school, Yale, Maryland, Johns Hopkins, and basically it's to design a bipedal walking robot which will walk over, get into a golf cart, drive it to a specified location, get out, go climb up a ladder, walk across a ramp, come down, get back in the cart, go drive to another location, pick up an impact drill, put a hole through a wall, get back in the golf cart. And it sounds like it's going to be a lot of fun, and we think we have a really, really good chance of being involved in that. So check with us in the fall to see if we do get funded, and there will be tons of opportunities for students. Here's the electrical engineering program for the freshman year. It's actually fairly similar to the civil engineering program. One of the big things is to notice the freshman first seminar, first semester, the university seminar in the second semester, the Math 121, 122 sequence. If you AP, we would simply move one of those courses up. What you see now in the next line is a slight bit more complicated. Typically, you will take Physics 121 and Engineering 131, this is as an electrical engineering major, in the freshman year. But it doesn't matter which semester you take it in. just so long as you take it in the freshman year. Chemistry 111, we've seen that in the civil engineering curriculum, then followed by the chemistry of materials in the second semester. At this point, you can take a humanities or social science, or even an open elective, either in the fall or the spring. And I would remind you that if you look at your FYI guide, which you should have been notified about, it has a list of courses which are especially for freshmen. So you may want to take a look at that. Okay, and Phys Ed. Nice picture of how all the courses relate. Typically the freshman year is down at the bottom. Notice the blue math, purple physics, and sort of the brown programming. This is computer engineering. It's virtually identical. This is the same, this is now the program shown graphically. Notice the same classes in the freshman, sophomore, early sophomore year. Computer science will end up becoming a little bit different. And notice what happens is that there aren't any classes which build upon the physics, or those particular Math 223, 224, they start a different math, discrete math, and go off into the 233 Intro to Data Structures and the 281 Hardware course. Mechanical engineering, there's one subtle difference between mechanical engineering and the other programs that we've shown. Notice that they have you taking Physics 121 in the first semester and Physics 122 in the first semester. Other than that, you see the same chemistry and materials, chemistry, let's see, Math 121, Math 122, and Engineering 131. It's just arranged slightly differently. Aerospace engineering is virtually identical to mechanical engineering. And at this point, that's the end of the prepared talk. And do we have any questions?
That was a lot of great information. Thanks, you guys. We do have lots of questions coming in. The first question is from Daniel, and he asked, even if you have the AP scores to place out of intro physics or calculus classes, is it recommended to do so?
That's not a question which can be simply answered. Usually if you have a score of 5, I would tend to say, yes, you probably want to take the advantage of the AP and move along in your program of study. If you've gotten a score of 4, you may want to actually talk to your advisor. And actually, one of the most important things that you can do is actually go sample both the AP course, that is the one that you would be getting into, and the one that you would have been getting credit for. For example, if you had a score of 5 on the BC, and the question was, should I take 122 or should I go on and take the 223? Go to both of them during the first week or so. You don't have to make a final decision until a little bit after the second week. So get the syllabus, meet with the instructor, and find out. But in general, I'm a little bit on the positive side and say, yes, but everyone is different, and let's take a look at it.
Okay, great. Now we have a question from Brian, who wants to know, do most classes in engineering, particularly the intro classes, require prior experience with these topics in high school? For example, if he's interested in computer science and must take the Java intro course, does the class jump right into the action, or is it at least temporarily tailored to beginners?
Boy, that's a long question. Actually, none of these classes are dependent on anything in high school, and they do not make any assumptions that you've got a high school background. If you do have a high school background, there might be some repetition of material, especially at the beginning. And particularly in the case of, for example, the EECS 132 Java course, if you've had background and you haven't taken the AP, I want to remind you that we do have proficiency exams which are given just before the semester starts, and that would be a good way for you to gauge, for example, your programming background. But you would definitely be getting right into the action.
Okay. Luke wants to know, what would a recommended major be if he tends to go to grad school in robotics? Would it be more CS or mechanical or electrical?
I would add to that list and include mechanical. We have an awful lot of students that, for example, do majors in electrical engineering, minors in mechanical, vice versa. I actually have in my briefcase, which is actually underneath the table that I'm sitting at right now, a master's thesis on basically a robotic tour guide that will take students prospective students down the hall and tell them about the department. That's done by an electrical engineer. But I've advised many mechanical engineers, and we do have some students in computer science who are also doing robotics, but that tends to be more in perception, both visual and audio, and also artificial intelligence. But those would probably be the top 3 majors for robotics.
Okay. So now Carrie would like to know, is she registering just for fall classes or for spring classes as well?
At this point, you would be registering for fall classes, but you want to keep in the back of your mind, and this is something you'll want to talk about with your advisor, what your program will continue on to in the spring.
Okay, I have a student who's interested in mechanical engineering, but wants to get really involved in other activities at CASE, whether it's work study, internships, and was wondering what kind of workload the program will entail their first year.
Oh, that's a tough one. It's really going to be very similar to all of the engineering programs, so I wouldn't say that it's any worse in electrical, that is any harder in mechanical engineering than it is in electrical engineering, than it is in civil engineering. Now, I would recommend, especially first semester, that you want to be cautious about taking on too many activities, whether they be work study, clubs, whatever. What you need to remember is that you're making a transition from high school to college, and it's very important for you to adapt to the proper workload and study habits that fit you.
Thanks. I just want to remind students we've got a lot of questions to answer, but if you do have a question, please send it to summerreghelp@case.edu so we can get as many of your questions answered this evening. But I do have a question now from Daniel, who said that you said that the computer science majors will take engineering 132. Is that the only option, or are there beginning level courses in different programming languages?
The 2 intro courses right now are the 132 Java course. That's the one recommended for anyone that's going to be going on into advanced software courses. There is the MATLAB course. That is much more of an engineering analysis and toolbox language, and we have had an occasional course, and by that it's not offered every semester, in C, C++. In the computer science program, there also is an upper class course that gets into multiple computer languages. But what you need for the intro data structures and software courses is Java.
Okay. Now we're going to go a little bit away from the engineering classes, and Mary would like to know, if she has credit for a liberal arts AP exam, would that count for some of the liberal arts elective requirements, or would she still need to take those elective courses at CASE?
No, that should count for the liberal arts requirements, yes.
Okay, we've talked a lot about AP credit. We have some students who have IB credit, and they want to know, do they get advanced credits like the AP credits as well?
Yes, they do. Yes, they do. There's just simply a different set of equivalents, which is based upon the particular courses that they took. And that is in their FYI guide.
Okay, wonderful. Now, we've talked a lot about the majors. We have students who are interested to know if people can still get a minor outside of the School of Engineering if they're majoring in engineering, or if they're restricted just to the engineering minors.
Oh, no, no, no. In fact, taking a minor outside of engineering can be both some of the most fun and some of the most rewarding things you can do. For example, we have any number of students who are doing minors. I just had a student graduated in electrical engineering with a minor in Arabic. But you can do foreign languages, that's very common. Economics is very common. Management, very common. Really, if there's something you're interested in, this is a wonderful time. Now, you might want to continue, for example, something that you have AP credit for that you started maybe in high school. Maybe you have AP credit for 2 history classes and you love it. Maybe you want to continue with 3 more classes. Typically, the minor is 5 classes and get a minor in history. But you could do political science, pretty much anything. And I really think those minors are wonderful at balancing you.
I agree that having those other minors really help just to kind of get you out of the engineering mindset once in a while, and you can develop other skills that you can use in your engineering curriculum. We have another question from John, who wants to know, does CASE offer any dual business and engineering degrees?
There is indeed a dual engineering and business degree, but it would be in the category of what we would call an undergraduate graduate degree. And I'm speaking specifically there of something called the Masters of Engineering and Management. Basically what happens is, and this gets into some of our more advanced programs, like the dual bachelor's master's program, but in this MEM program, you apply to the program in the junior year, and then you do 2 industrial internships, I believe it is, and you're taking graduate courses which are being taught in a joint program by engineers and faculty from the School of Business. And the end result is you would get 2 degrees, your engineering degree and your master's in engineering and management.
Thank you. First of all, we have someone who emailed in and said they love the Elmo tie. So kudos on the Elmo tie, Professor Merat. Now the question is, I'm considering learning a foreign language and perhaps minoring in a foreign language, and would like to know what language would be most valuable to a graduate trying to get a job in the engineering field, particularly in the computer field.
Boy, that is a really tough one. I would almost say that you couldn't go wrong with picking a language. You know, for example, a good knowledge of Arabic might be really, really valuable to someone who's interested in, for example, automatic language translation. Certainly there are booming economies, especially in China. I mean, those are 2 to consider right there. But you can also do a lot without having a minor in language. I would have to say that over the years, the most popular foreign language among the students that I've advised has been Japanese, and especially some of the junior year abroad programs and the programs where they spend time in Japan.
Wonderful, wonderful. Now I have a question from John, who wants to know if you could again review the classes that students would take if they were going to major in computer science, and is it similar to civil engineering if there's an opening for an arts and humanities class in the phys ed class?
Yes, there is. Basically, the freshman year is very, very similar. The only major difference is notice the substitution of the EECS 132 course, the Java programming course, for the the ENGR 131 MATLAB course. But you need to take the same math, the same physics. Now, things would be slightly different if you had significant amount of AP credit and you might be moving some of your sophomore courses into your freshman year.
Great. So we have a student who's not sure what engineering discipline they want to pursue, and they want to know how to decide between the fields and how easy is it to change from one to the other as they're going into this.
Okay, first thing is, and Dario was mentioning this, get involved with the departments. There are going to be a lot of information sessions. You want to go to them. Second thing that you want to do is get involved with some of the interesting student groups. They will have open houses, seminars, all kinds of events for freshmen. They will be at the various fairs during orientation. Just find out what's interesting. Also, once you pick a major, this is not a lifelong commitment. It actually is pretty easy to change. Since the first year is very common, and even it extends into the middle of the second year, between most majors, it's quite easy to switch back and forth. And between some majors, the differences are so small. For example, between computer science and computer engineering, I have students switching back and forth in the second semester of their junior year. So it actually is fairly easy to switch back and forth. And by the way, I do want to point out the value of intern programs, co-op programs, and other things like that in helping you clarify what major you want to be in your career goals.
Frank,
Wonderful.
there's also an opportunity for dual majors.
Yes, there is.
Okay, so you can, for additional courses, you can also satisfy requirements for a dual major. Let's say you're interested in civil or mechanical or electrical and computer science, so you can do dual majors as well.
Great. That's a perfect lead-in for the next question that I had, Dario. We have a student who wants to know if they take engineering courses for their major, can those courses be counted towards a minor or another major within engineering?
Yes, indeed. Yep. Each department defines their own minor requirements, and you have to look at the general bulletin, and it will describe the 5 sets of courses that are really prescribed by each department, and they are often courses that satisfy both degrees.
Okay, now we have a question about the math placement score. Someone's concerned that if they are placed into Math 120, that they maybe get behind in engineering or they won't be able to pursue a degree in engineering. Can you talk a little bit about how Math 120 works into their program?
Math 120 is usually taken in the first semester. As I recall, that is to a large extent a self-study course, but a supervised self-study course, and you really do not get behind. If you take a look at your programs, all that matters is that you get into your 121 and 122 by the middle of the sophomore year.
Great. So now we have people who are interested in outside projects and want to know, are there research opportunities available for first-year students within the school?
Yes, there are. You will have to go talk to, and I mentioned earlier, the source, our office, which basically is the matchmaker between undergraduates and research faculty. But you can also just go online, take a look at the department web pages. One student told me that he was interested in doing some research in computer science in the networking area, sent an email to a faculty member at 10 o'clock at night one day, got an email back within about 10 or 15 minutes that said, well, that's not exactly my research area, but gave a follow-up, named a contact. He contacted that person. That person fired back within 5 minutes with something like 10 to 15 different topics that the student could get involved with. The student did get involved and actually went on to do a bachelor's and a master's in that area, which related to internet trafficking.
Now I have a student who's interested in just the first year courses in general. They want to know, what are the engineering courses like? Is there a lot of homework? Do students work in study groups? Is it really individual? Could you maybe talk a little bit about the first year courses?
Every student probably studies and works differently, but what I have seen in all of the time that I've been working with freshman engineering students, they work together. There's a lot of teamwork. You develop study groups. If you take a look at the way the dormitories are organized, the first thing you're going to do is look for colleagues, students that are in the same classes. You're going to work together a lot. And there are also study areas in various locations around campus which encourage you to get together, have meetings, etc.
Looks like we're going to have a bunch of athletes in the School of Engineering this year. We've got a few questions from athletes who want to know, if they are a student athlete, are they able to participate in the co-op or internship programs?
They can, but it may interfere with some of the sports because it depends on what semester. For example, if they're playing football in the fall, then they could consider a spring and a summer co-op program. So there's going to be a little more attention that will have to be paid to the scheduling, but yes, it can be done.
Great. We like lots of athletes over in engineering. Now we have a question from someone who wants to go to law school and is wondering if there are any engineering majors that you could recommend for someone who wants to go into the law.
I would say all of them. Basically, the patent office, well, I'm thinking, as soon as I think of law, I think of patent. That was probably a little bit of a jump on my part. But the big thing is that the logical thinking that you learn how to do in engineering is a perfect match to law. So I would say any.
Great. Now we have a student who's not sure if they want to do physics or engineering. How might they, what suggestions might you give them on helping them decide which way to go or what courses they might take their first year?
Okay, that's an interesting one. I think one of the big things is you would see a little bit of that in the difference between, say, a physics course and potentially something like the Engineering 145 course or any other engineering course that they might be taking. And you might even look at a compromise like the engineering physics program, which actually straddles both schools and has a core of physics courses with electives from the various engineering departments.
Thank you. Now we have Dario piqued the interest of a student with the intro course you're talking about in civil engineering.
Yes.
I believe it's 116. They want to know if it's a required course or not for the program.
Yes, it is required, but for the sophomore year, the class is generally a mixture of freshmen and sophomores. So you're welcome to take it in the freshman year if you want to have those skills for the summer. But it is a required course in our sophomore year of our curriculum.
Great. Dario, can you talk a little bit about the range of faculty interests within the Department of Civil Engineering?
Sure. Civil engineering has 4 or 5 major areas. One is structural engineering, in which are designers of structures and bridges and buildings. We also have geotechnical engineering, which is a discipline that works with soils and rocks as engineering materials. For example, dam design or foundation design. We also have environmental engineering. Environmental engineering is a facet of civil engineering in which they work on remediation, solid waste disposal, and water purification systems. Especially, we've had several of our students that are involved in Engineers Without Borders, and they have collaborated with Engineers Without Borders in their activities, because many times third world countries are the public health is a very important issue. The other one is construction management. So those are the four major areas that we have.
Thank you so much. We have a student who's concerned about kind of transitioning into the university setting and want to know if they only take 14 credits of courses in the fall semester just to kind of get acclimated to the university, will they be behind in their major?
No.
No,
That's actually moderately common, and it's a very good tactic, I think, for anyone who does have concerns about that transition from high school to college.
I concur, Frank. I think that's a good, intelligent decision. If you feel that you want to make it, it's a good decision.
Great. You talked a little bit about the study abroad opportunities in your presentation, and we have a few students emailing in wanting to know when would be the best time to study abroad, and when they're there, would they be able to take engineering classes, or would they be taking arts and humanities, social science classes?
Typically that would be in the junior year, and they would typically be taking technical courses. I just had a young lady get back from a university in Berlin where she was taking classes in computer engineering. Interestingly, they were all Linux-based, and they all counted towards her undergraduate degree. I had some students that were in New Zealand. They were actually taking courses in power electronics and communications, which we didn't offer here. So that was actually an excellent complement to their degree program, and they did not lose a single thing and gained a terrific experience by doing it.
Studying abroad is a great experience. We have a question from Alex who wants to know, what are some of the more recent multidisciplinary engineering projects concerning the biological sciences?
Oh, I just happen to have an example right there of one. I don't know if this is quite the biological sciences because this is more in the rehabilitative area. We had an electrical engineer who had a minor in biomedical engineering, and actually he got a Fulbright scholarship, and he went to a school in Ireland where he was working on speech synthesizers for the handicapped.
Great. We have someone who's been diligently looking over the engineering website, it looks like, and saw something about the ThinkBox and wants to know a little bit more about what the ThinkBox is, how can students use it, what can they do there?
They can do anything there. It will require a little bit of training. We have the ThinkBox, and for those of you who don't know what it is a wonderful facility that will allow you to fabricate almost anything you want. It includes things from laser cutters, large laser cutters, three-dimensional printers, standard machine tools. As you can tell, I'm a little bit in love with it because I like building things. But there will be training involved. We're working on setting it up online. The training will be an integral part of the curriculum, I believe, in mechanical engineering. Is it also in civil engineering? I believe it is.
No, I don't think so.
It isn't?
No.
Okay, and I know one of the tracks in biomedical engineering. Several of the freshman seminars will be using the ThinkBox, and we encourage you to just go in and start using it. It's in smaller quarters for the moment, but we hope that it'll soon be moving to much larger quarters.
Just to add a final point, it is intended also for other than case students and other than case engineering students. So you'll be interacting with students from the Cleveland Institute of Art, possibly, or the College of Arts and Science students. So that additional interdisciplinary effort takes place in this ThinkBox facility.
Yeah, I've actually been down to see the ThinkBox. I'm not an engineer, but some really cool equipment down there, so I do encourage people to use that. Now we have a student who's interested in computer science, but's not sure if they want to go the BS or the BA route, and was hoping you could address the pros and cons or the differences between the two.
Okay, that's a real interesting question. At first, there is no difference between the two. What the longer-term difference is 122 credit hours required for the BA versus 128 credit hours required for the BS. What happens is that The BA student takes the same technical courses, but simply fewer of them are required for the degree. The BA is really designed for those people who want to have double majors or minors. For example, we have any number of BA students in computer science with a second degree that they're working on in, for example, biology or economics being probably the two most popular.
Frank, do the BA majors have to take the engineering core?
They take the engineering courses in the freshman year, but not the engineering core. And that is true of computer science in general. They do not take the 200 courses.
Oh, I'm sorry. We have a student who'd like to know if they can take required engineering coursework over the summer at another school.
Yes, you can do that, but you need to typically get pre-approval of that through the Office of Undergraduate Studies, and they will work and check with your home department about that.
Typically for the upper level courses, they are judged to be equivalent by the individual departments. So individual departments evaluate whether a course taken during the summer satisfies the requirements for that particular major. For some of the basic courses, those are determined by the Office of Undergraduate Studies.
Great. Now, someone wants to know, Karen, I won't call her someone, wants to know how many credits is recommended during your first year?
That varies. I'm thinking on the general order of if you have 16 to 18 credits per semester, maybe even a little bit less. I would say usually 30 to 32, but it may be more.
Great. And we're running out of time, so we have one last question, and maybe both of you can address it from your respective departments. But a student wants to know, what's the best way to get to know faculty members within their department?
Oh, that's a fun question. First one is, if you're taking a class from them, just go up and talk to them after class, or ask questions in class. Go to department seminars. This is something that's very much ignored by freshmen. Every department will have a web page, and they will have all kinds of interesting seminars. Go attend. And they'll usually have, by the way, coffee and donuts or other food there. Dario, do you want to add to that?
Typically each department has open houses as well. So just attend the open house, and that's where you meet some of the faculty and some of the undergraduates. So please come to some of the open houses of the individual departments.
Great. Thank you, guys. We're just about out of time, so I do want to thank everyone who listened this evening. We did get to most of the questions. If we did not answer your question this evening, we will email you. And now I just want to ask our hosts if they have any final words of wisdom that they'd like to impart tonight.
Get engaged. Have fun.
I completely concur. I also advise you to visit the university website and really look over the first year information guide. And if you're interested in the second to fourth year of curriculum, just go to the CASE General Bulletin and look at the 4-year curriculum for each one of the disciplines. And really, this is what you will be responsible for your 4 years here at CASE. So go look at our website, the PDF of the General Bulletin, and download the pages of the major that you're interested in. And these are the courses that you'll be responsible for. But have fun and enjoy your stay at CASE.
Thank you very much. I want to thank everyone for sending in their questions and for joining this evening. I want to thank Professor Merat and Professor Gasparini for being with us.